Hello children, I am here again with another chapter of chemistry, class 10th, and that is electrolysis. Now, what is electrolysis? Let's begin with that. Now see, definition of electrolysis is, it is the process of decomposition of electrolyte. And what is electrolyte? It is a chemical compound. We will discuss it later. Electrolyte in aqueous or molten state by passing direct electric current. Direct electric current means it is supplied through battery. Okay, it is not that electric current we are getting at our home. This is the electric current which is supplied by battery. Why we are using battery? To get the continuous flow of electric current. Okay. So when the electric current is continuous, the electrolysis process will be very smooth. Okay. Now see, what are electrolytes? Just now I have explained that electrolyte is a chemical compound which is dissociating into ions. Okay. The compound which dissociate into ion. Okay, what is electrolyte? The compound which is in aqueous means in the form of solution, aqueous or molten state. Molten means when the compound is melted in the melted form. Okay, molten means it is in the melted form, and aqueous means it is in the form of solution. Okay, when compound is in aqueous or molten state, it dissociates into its ion when direct current is passed through it. Okay, it dissociates into ion. Let us take one example of sodium chloride. Sodium chloride is a compound. Okay, when you will dissolve this NaCl in water to make it aqueous solution, so what happens? This NaCl dissociates into ion. Na will form Na plus ion and Cl will form Cl minus ion. So you can say that this is electrolyte. Okay. Electrolyte is a compound which dissociates into ion when it is in aqueous or molten state. Okay, it is clear to you all? Now, types of electrolyte. There are three types: strong electrolyte, weak electrolyte, and non-electrolyte. We will discuss strong electrolyte first. So first, strong electrolyte. Strong electrolyte is that compound which may come from acid, base or salt. Okay. So if any acid, that is strong acid, then you can say it will act as strong electrolyte. That means it will dissociate into its ion when electric current is passed. So strong electrolyte is H2SO4, HCl and HNO3. This is strong acid. Now next is base. The strong base. Strong base means it will dissociates completely into ion in the aqueous form. NaOH, KOH and CaOH whole twice. And next is strong salt. Any compound which is strong salt like NaCl, K2SO4, CuSO4. Now how do you identify any compound is strong salt? See, NaCl is formed by NaOH and HCl. You can see that NaOH is strong base and HCl is strong acid. So the salt form will be strong salt. Okay. So any acid or base, either both are strong or any one of them is strong. So you can say it is a strong salt. For K2SO4 you can say KOH, it is a strong base, and H2SO4, it is strong acid. So the salt form will be strong salt, K2SO4. Same here, CuOH whole twice plus HCl. But here you cannot say that CuOH whole twice is a strong base. But one component must be strong. Acid is strong. So you can say that CuCl2 is a strong base. Either both acid or base must be strong, or any one will be very strong, then the salt form is a strong salt. Now weak electrolyte. Weak electrolyte is either from weak acid, that is acetic acid, and weak base, ammonium hydroxide. Okay, so here why they are weak? Because dissociation of these compound into water is not complete. Okay, some are in the form of ion and some are in the form of molecule. So you can say weak acid and weak base will form weak electrolyte. What are weak electrolyte? They will not dissociate completely into its ion. Okay, now next is, now what are non-electrolytes? Non-electrolytes are the compound which do not allow electric current to pass through it. Okay, the compound which will not allow electric current to pass through it, it is called non-electrolyte. Either it is in aqueous or in molten state. Okay, so it will never allow electric current to pass through it. Some examples are urea, sugar, distilled water, alcohol, kerosene. These will never allow electric current to pass through it in aqueous or molten state. Now let's differentiate between strong electrolyte and weak electrolyte. Any compound which dissociates completely, okay, when it is dissociating completely in molten or aqueous state, then you can say it is a strong electrolyte, like KOH, K plus and OH minus ion. These are dissociating completely, so it is a strong electrolyte. Here the compound partially dissociate in molten or aqueous state. Okay, in molten or aqueous state, it is not completely dissociating. Like acetic acid, it dissociates into CH3, COO minus and H plus ion. Here the dissociation is partial, so you can say it is a weak electrolyte. Here large amount of current can flow through them because they are forming large number of ions, so current will flow more easily. Here small amount of current can flow through it because the molecules and ions are present in the weak electrolyte. Here when bulb is connected through the circuit, it will glow very brightly because large amount of current is flowing through it. And here the bulb will glow dimly because small amount of current is flowed through it. And why this is like that? Because solution in the strong electrolyte contain only free electrons. Okay, and in the weak electrolyte solution contain ions as well as molecule. That's why the bulb glows dimly, and here only free ions are there. That's why the bulb is glowing brightly. Now here one question comes in your exam, that why solid NaCl is a non-electrolyte. Just now I have explained that NaCl is formed by HCl acid and NaOH base. Both are strong acid and strong base. So you can say that it is a strong salt, so it may conduct electricity. But why solid NaCl is not conducting electricity? Okay, so you have to give the answer for that. Here you can say that NaCl is in the solid state. Okay, and in the solid state the bond or force of attraction between sodium and chlorine is very strong. What type of force is acting? Yes, it is electrostatic force. Okay, electrostatic force is acting between sodium and chlorine. So this force of attraction is very strong. What happened when they dissolved in water? This force of attraction gets weaker, or they will converted into its ion, Na plus and Cl minus ion. Okay, when they are dissolved in water or they are in aqueous form, means when NaCl is in solid state, the electrostatic force of attraction between them is very strong, so they are not forming ion. See, there is no ion, and when they are dissolved in water, they are forming ions. So where there is ions are forming. They can conduct electricity. Where there is no ion, they will never conduct electricity. So you can say that solid NaCl is a non-electrolyte because a very strong electrostatic force is acting between them in the solid state and no ions are present. That's why they will not conduct electricity. When they are dissolved in water, so they will form aqueous solution and they will form ions of respective element. And because there is ions present now, they can conduct electricity. Okay. Now next is metallic conductor and electrolytic conductor. Metallic conductor, we will take one example of copper wire, and electrolytic conductor, we will take example of copper sulfate solution. Okay. Now see what is happening here. In metallic conductor, copper wire is very good conductor of electricity, and electrolytic conductor, copper sulfate is a salt which is formed by CuOH whole twice and H2SO4. Strong acid is present, that's why it is a strong salt. It will conduct electricity. Okay, so see here, copper wire and copper solution. So first thing you have to note that copper wire is in the form of solid state and this one is in the form of liquid or molten state. Okay. So first difference is that metallic conductors are in solid state, electrolytic are in aqueous or molten state. Second point is then, third is that here in the wire no ions are forming. Electron will flow from one end to another end. Okay, electron is flowing into the wire from one end to another end. Here electrons are not present. What are present here is ions, Cu2 plus and SO4 2 minus ion. Here ions will flow. Okay, here ions will flow. Here electron will flow from one end to another end, and in the solution what will flow? Ions. Okay, positive and negative ions. Cu2, I will write here Cu2 plus and SO4 2 minus ions. Now fourth point is that no chemical change will take place. Okay, no chemical change. When electron will start flowing in the copper wire, copper will remain same at the both end. Okay, there is no change. Copper here also, copper here also, and here there is a chemical change. Okay, chemical change will take place. Why? Because copper sulfate is now converted into Cu2 plus ion and SO4 to 2 minus ions. Okay, so here it is a chemical change and here it is no change. Here why it is a chemical change? Because decomposition of compound is taking place. Here decomposition is taking place, that's why it is a chemical change. Here no change is taking place. First copper is there, after the flow of electron copper will remain as copper wire. Okay, here also copper wire, only electron will flow from one end to another end. Now here question arises, where electrolysis, this full chemical reaction take place? Where this electrolysis take place? So the answer is it take place in the electrolytic cells. What are electrolytic cells? We will discuss this now. Okay, till now we have done electrolytes, conductor, electrolytic conductor. Now where these are used in the electrolysis? Where electrolysis take place? In the electrolytic cell. Electrolytic cell is also known as voltmeter. What is the function of this cell? It converts electrical energy, that is DC current, direct current, into chemical energy. Okay, electrical energy into chemical energy. Now let's see how it is, electrolytic cell, how the arrangement is there. This is non-conducting it is non-conducting vessel in which electrolysis take place. Okay, non-conducting means whatever electrolyte is present here, electrolyte is a solution of a compound. It is in molten or in aqueous state. So this is electrolyte, and this one is non-conducting vessel. Okay. Why it is non-conducting? Because if it will conduct, then some of the ions from vessel also goes in electrolyte. That's why we take non-conducting vessel in which electrolyte can only dissociate. In this vessel, electrolyte is present as well as these two electrodes are present. Electrodes are the rod which is, one is negative and one is positive. Okay. The function of electrode is that it will convert ion into its atom. Okay, or you can say it will discharge ion. It will discharge ion. Okay. The function of electrode is to discharge ion. Ion is here. Discharge means to remove the charge. So it will convert into Na, like that. Okay, discharge ion. It is made up of platinum, carbon rod, or any metal. So electrode is made up of platinum, carbon, or any metal. What is the function of electrode? To discharge ion. What is discharge? To remove the charge. Okay, whatever charge is on the ion, its function is to remove that charge. Okay. Now let's understand how electrolysis take place in this vessel. Let's take the example of NaCl. Okay, so when NaCl is in the aqueous form or in molten state, what will happen? Na plus and Cl minus ion will form. Okay, Na plus and Cl minus ions will be there in the solution. After battery is connected, that means DC current is passing through this circuit. When current will start flowing, what happen here? Positively charged ion will move towards negatively charged electrode. Plus will move towards minus, and minus ion will move towards plus. Okay, so what is happening? Na is moving towards minus electrode, and in this minus electrode, so many electrons are already present. So Na plus will move towards minus electrode and Cl minus will move towards plus electrode. Now how you will identify? One trick is there to remember this plus and minus electrode. NCr and PaO. What is NCr? N is stand for negative, C is for cathode, and R is for reduction. That I have taught you in class 9th also. And PaO. P is for positive, A is for anode, and O is for oxidation. Okay, positive anode oxidation. So what will you will see here that plus what anode is positively charged electrode and oxidation will take place at anode. NCr negative. Now the ion which is moving towards cathode is called cation. So here you can say Na plus is moving towards cathode, so it is cation. Okay, and the ion which is moving towards anode, Cl minus, anode, and that's why it is called anion. Okay, the ion which is moving towards cathode is negatively charged, and that ion will move is positive charge. So the ion which is moving towards cathode is cation, and the ion moving towards anode is anion. And PaO, positive anode oxidation. What is oxidation? Oxidation is loss of electron. You will use oil. What is oil? Oil is oxidation is loss of electron. And for reduction, what you will use? Rig. What is rig? Reduction is gain of electron. Okay. OIL, oxidation is loss of electron. Rig, reduction is gain of electron. So oxidation of sodium, see here, it is electronic configuration is 281. Loss of electron means one electron we are removing from sodium. So this electron is removed. So Na will be Na plus now after loss of one electron. And electronic configuration for Na plus will be 28. So you can say that Na plus is oxidized. And for chlorine, electronic configuration is 287. Reduction is gain of electron. That means here electron is gained by chlorine. One electron we are adding here. So it will be 288 now, and Cl minus ion will form. So minus ion is forming. That means it is electron is gained by the atom, and plus ion is forming. That means electron is loosed by an atom. Now next is electrolytic, dissociation and ionization. What is the meaning of dissociation and ionization? Dissociation will take place for ionic compound. Ionic compound. Dissociation means to separate. In ionic compound, ions are already present, plus and minus ions are already present. So in ionic compound, ions are present, you have to just separate them. So this is called electrolytic dissociation. It will take place for ionic compound like KCl, K plus and Cl minus ion. Okay, this is ionic compound in which ions are already present. How ions are present? Let's see here. K plus and Cl minus ions, they are attracted by strong electrolysis for electrostatic force, and due to this force they are very strongly bonded. So you can say electrostatic force is acting between plus and minus ions. So it is very strong bond, and it will not dissociate in the solid state. In the molten state, it dissociates into its ion, K plus and Cl minus ion. Now, electrolytic dissociation is done. This is for ionic compound. And ionization is for covalent compound. Covalent compound means there is no positive or negative ions are present. Covalent bond, there is no positive negative ions are present. You have to create or form positive and negative ion. Let's take one example of HCl. In HCl, no plus and minus ions are present. It is a covalent compound. So what you will do, you will form ion for these H plus and Cl minus ion, and when it is dissolved in water, so it will dissociate into H plus and Cl minus ion, and HCl is polar covalent compound. Okay, so it will dissociate into H plus and Cl minus ion, and after dissociation then only it will conduct electricity. So dissociation, you have to just separate, ions are already present, and ionization, first you have to form ion, and after that you have to dissociate it into plus and minus ions. Okay.